Good morning, good afternoon, good evening, and welcome back to the MineWarp podcast. This is Empie Strydom, your host, as usual. And our guest today is Michelle Ash. She is CEO of SIMULIA at Dassault Systèmes, and one of the global leaders in engineering simulation and, as we'll hear, virtual twin technology. So Michelle, I'm sure, is no stranger to many of you, but she started her role as CEO about 9 months ago. Michelle, is that right? At SIMULIA?
Yes. In
Yeah.
September. Yeah.
And she's also no newbie to industrial and mining technology. She has a role as board member to multiple tech and innovation companies. She's earlier had roles as VP Growth at BHP Billiton and board member of the GMG, which is also very interesting, developing mining standards and so on, and then technology exec at Oz Minerals before that, and CEO of Geovia, which is another Dassault company.
Yeah.
So it seems you just can't stay away.
I know. I'm a resec. I just keep coming back, no matter where you are. Yeah.
Yeah. So now, Michelle, let's get to know you a little bit more. So why don't you just tell us a little bit about your background? How did you become so wanted in the industry?
Absolutely. So look, I've been working in mining now for over 30 years, somewhere between 30 and 35 years. Originally a mining engineer, or in fact, originally a civil engineer, came into mining. Wasn't originally. I thought I was going to build bridges and skyscrapers, and but got offered a role in mining. And as many of you will know, once you get into mining, and especially I was a blasting engineer, so all of my anarchistic tendencies at early age were able to be put into my work. But honestly, the people in mining, being part of that mining process, fantastic. And I've loved it ever since. I've been lucky enough to work in operational roles, everything from, blasting engineer, as I said, running maintenance workshops, running processing facilities. I've worked around the world, in Southeast Asia, Australia, North and South America, parts of Europe, so fantastic opportunities. Africa, many African countries, chief operations officer for Acacia at one point, but also in strategic roles, which has been super fun as well. I was head of strategy for China Minerals, which was a great foray into, how Chinese state-owned enterprises work, and that's sort of how you bring East and West into an organization. With MMG. I worked for Mitsubishi and again, understanding how the merchant organizations work, but also as part of, BMA and developing some of those assets. So, great opportunities, as well as, some of the ones that you've spoken about. But I think in the last 10 years, I've started to get more involved in the technology side of mining, as chief innovation officer for Barrick. And then when I left Barrick, really wanted to. So my fundamental view, I think, of mining, or of any industry that creates a physical product, is that we are, and especially with artificial intelligence and the capabilities that are coming forth, we're going to have to start thinking of ourselves not as a mining company, or a company that creates ore, or makes copper, or whatever it might be, but actually as a virtually enabled company that happens to create copper. So if you're a car manufacturing company, rather than being a company that makes cars, you're a digitally enabled company that happens to make cars as your product.
Right.
And I think for me, that transition is going to be very important to optimize and to, ultimately drive productivity in these organizations, and therefore deliver to the world, better, cheaper products that are less environmentally impactful, etc. So because of that, I really felt that it was important for executives in these heavy industries, which is where I come from, and my love, to really understand technologies, and to do that, be fundamentally part of technology companies. So,
Mm.
you know, the reason why I entered Dassault in the first time when I was CEO of Jorbia, and now the opportunity to come back to Dassault, and especially at this point in time, where, as I said, AI is a massive technology transition that's going on in the world, and going to transform not only all industries, but even what we do in our daily lives. And you know, why I encourage people to get involved with AI, test it, try it, be skeptical of it, and
Yeah.
question it. But that's, you know, what we all should do. But you know, combining that with simulation, which has always been, I think, fantastic, because you know, some of our simulation tools allow you to really understand how a product or how an object is going to behave in the real world before you even have to build it. So, you know, if I want to know, you know, how my car is going to behave with this, you know, change that I'm making. You know, if I'm a backyard car expert, you know, I'm going to change the engine in some way. If I want to run that virtually, understand exactly how it's going to behave, what's going to happen, I can do that using these simulation tools, and then I can make the change knowing that it's optimized. You know, so you imagine that if I can do that in my backyard with some of the things that I might do, what that does then, if I'm a company that makes a physical product, I can make this product. I can simulate it in different use cases or different ways of it engaging in the world. I can even think about how I'm going to manufacture it. I can think about where I might get those components from, how they might be manufactured. I can even think about how it's going to be used in use and run use cycles and maintenance cycles, etc. And maybe even its whole circle of life. I can do all of that virtually, create this sort of universe for this product before I ever have to build it physically. So that's, for me, such an exciting concept and exciting opportunity to be part of.
You know, two things came to mind as you were talking, and so you can comment on both. The first is it's quite a departure from someone who, you know, even as an operations, or someone like you with an operations background, for whom everything was about the physical product, right? To make a move to simulation where you're working not even with a digital twin, but with a virtual twin, you know, so you're really going to vaporware as the product, you know,
Absolutely.
so to speak. And then second thing that came to mind was, you know, you were talking about the mining companies that have to, or mining executives that have to understand technology. But in my mind, it's almost as critical, if not more, that companies learn how to adopt technology.
Yes. Oh, yes.
And not only you know, I've spoken with a few university professors and deans at mining schools about, you know, about this. I've asked him, do you teach your mining engineers and your geologists and so on how they should think about adopting technology? So here's the question: do you think that this virtual world will have an impact on the ease of adoption of technology, or will it be another hurdle that has to be overcome?
Yeah, so I think both. I mean, I think there are um, let's divide that into three pieces. I think the ability to be able to really create a virtual twin of a product, so that you can really understand that product very intimately. You know, and whether that's ore, whether that's a car, whether that's a pump, you know, whatever that product might be.
Right.
And you can understand how it's going to be used. You can interact with it. You can optimize it. You can, you know, understand how it's going to be maintained and its maintenance cycles. And you can even, you know, take it into a mining context. You could put it into a processing plant. You could run that processing plant with that new product or that new innovation in it. That ability should also drive more ready adoption, because we can solve a lot of those human problems, and we can solve even just the problem of how's it going to work, why, you know, how's it going to fit into my operation, how am I going to maintain it. all of those
Mm.
challenges that come up when we want to put a new piece of technology in. But currently, we tend to do it essentially trial and error. We
Mm.
conceptualize a new technology and then we go, well, that's sort of good. We'll put some prototypes together. We'll maybe shove it into somebody's processing plant.
Mm.
And then, of course, all of the operational folks are going, oh, like we don't know
Yeah.
how to maintain it. Some bananas put this so
Why did you
close
have to
that you
choose
can't
my
even get
plant?
in. Yeah, why do I have to run it? It doesn't run
Yeah.
properly because no one thought about this outlet or that new pump.
Yeah.
So, all of those challenges can be resolved. And because they're in a virtual twin, which is a 3D model, completely down to every nut and bolt,
Mm.
you can really get lots of people to engage in it. And now there's lots of technology that you can use. You can use
Mm.
virtual, technology, other things to sort of
Virtual reality
allow
and
people to
augmented
virtual reality,
reality.
yeah, so you can submerge into it and things like
Mm.
that. So I think there's a lot of opportunity to engage people very early on and then optimize even
Mm.
for the human element. I think the other component to that answer though is, I think as engineers, sometimes we are very focused on the technology or the technical thing,
Mm.
and we're not so good at, you know, the economics around it
Mm.
and the human element around it. So, I often talk to people about three components of innovation. It needs to be, um, you know, feasible. So,
Mm.
technically it can
Right.
work. Great. We've got a technical feasible solution.
Mm. That's the
It has to
ticket to the
be,
game.
yeah, exactly. Past number one. It's got to be viable, which means you've got to have a business case around it that makes sense and, gets you an ROI and all of that sort of
Right.
stuff. But it also has to be desirable. So you have
Mm.
to ensure that the product is able to, or the innovation is able to then be
Mm.
readily adopted, easily adopted. How do I set people up to because and this is going to make their life easier. They're going to want to
Mm.
do this because there's always these adoption hurdles because I'm taking someone from what they're doing at the moment to another solution.
Mm.
And if the adoption hurdle is higher than the value I'm going to get on this other side, of course I'm not going to do it. I'm going to grumble
Yes.
and complain. And so, both how do we make the value higher on the other side, but how do we make people recognize the higher
Yeah.
value on the other side? And again, I think some of these
Yes.
technologies, the virtual twins, can be super helpful with that because people can interact and love the solution well before I'm even physically building it. And then I
Mm.
think the third component of that is that, you're absolutely right. Part of the rationale of mining executives understanding technology, understanding how technology companies work and function, and then understanding how you adopt technology is so that as mining companies or as executives running any physical product company or any
Mm.
heavy industry, it is those three components that have
Mm.
to come together. We have to understand the technology and how it applies in our
Mm.
business. We then have to be a super good partner to work with companies that are supplying that
Right.
product, and therefore we have to understand them because this is going to be a long-term partnership. These aren't just products we're going to use for a
Yeah.
day or two, a year or two. We're going to use them for 10, 20, 30 years. And then, thirdly, we have to really understand how we're going to get rapid and high adoption rates in our
Mm.
organization so that we can get the transformation and we can reap the benefits at the end of the day by the thing being utilized in our organization. And I think at the moment, the one that is, we haven't most probably got enough executives understand technology. We've got
Mm.
more board members, which is sort of
Mm.
nice, but we need to enable our executives. Um, we're not always the best of partners, but we're getting better in mining. But
Mm.
there's still more that we can do to really understand these collaborative environments
Mm.
and how we work within them. But certainly better than
Yeah.
2015 when I started this journey. So it's been 11 years, but it's been a
It's been a while.
good ride. I
Yeah.
think the area where we're most probably least enabled at the moment is this cultural change and the
Mm.
adoption piece, and especially because I think one of the key competitive advantages going forward is going to be not just rapid adoption in a part of my business, it's how do I then adopt and scale it across my business. And there's so many companies inside mining and outside mining where that is true. We're still struggling with that component.
So on the topic of scaling then, do you, I don't know if the question is, do you foresee or when do you foresee, you know, that mining companies will eventually maintain live virtual mines, I almost want to say, on which they test everything before they do it on the physical mines. Is that a pipe dream, or do you see that becoming reality?
So look, I don't think it's a pipe dream. I can see it being a reality. There may be other heavy industries that go before us in mining, and in part because mining has a lot of complexities to it. Because if you think about mining, we are a small power plant. We've got town facilities or camp facilities. We've got processing facilities. We've got equipment running around, et cetera, et cetera.
Yeah.
The nice thing, though, is that if we got this partnership right, all of those pieces are owned by somebody in our supplier group within our ecosystem. So we could work with them to bring their virtual twins into our broader virtual twin or our more universe, and interact and integrate those. So I think there are many opportunities for us to fast track if we would just use that ecosystem and align that ecosystem.
Yeah. So you've used the term universe there, which brings to mind, for me at least, this an expansion beyond maybe your immediate area of interest, and how your area of interest interacts with other areas of interest. So
exactly.
Do you then foresee this as like a multi-virtual twin universe that of interconnected simulations that represent entire systems, or how does that work?
Yeah, look, for me, again, you can start small and you can grow big. I mean, I think, the nice thing about the concept of virtual twin and then the reality that can be brought is that, it could be as simple as a product as a bottle. But even that bottle can then, live within, a manufacturing environment where you've got a, manufacturing facility, you've got a transport environment, etc. So you can expand that very simple products universe to its interconnections and then solve systemic problems and solve systemic integrations, etc. Or you could take something more complex like a haul truck, for example, which, its corollary is a car, I guess, in transport and mobility industry. And you could integrate that into the virtual twin of a processing plant. And then how do those two things interact? Which is, yes, more complex, but conceptually still part of just a bigger system.
Right.
And I think as compute power becomes cheaper and faster, and I think that's one of the great things that we're seeing, leaders like NVIDIA, et cetera, are driving. As you start getting GPUs into cloud environments, some of the latest GPUs, you're getting sort of 10x speeds, if not more, and you're getting, therefore, 10 to 100x cost reduction per compute. It starts putting some of these things that maybe years ago you would have gone, it's going to take so long to integrate them. It's not feasible. Yeah, exactly. You're not passing point one in terms of feasibility. Now we're getting more feasible. We're starting to get more viable. And, every generation, which is happening every 2 years, will be driving that viability component. And now it's kind of create that, as I said, desirability. How do we actually make it easy for people to plug and play some of these things to look at that systemic?
Some of my engineering friends are concerned, right? About this world of AI.
Oh, yeah.
Now, I know there's a difference between, general AI and this narrow, specific AI solvers, for that matter. But, AI has this risk of hallucinating and generalizing everything. And the question is, if AI can then approximate kind of really well enough, or reality well enough for many of these engineering decisions, does that eventually reduce the need for deep specialist expertise? And what happens when we start crossing that line between approximation and
Yep.
engineering truth, because engineers are
Yeah.
supposed to find not only ideal solutions and beautiful solutions,
Yeah.
but they actually have to be
Yeah.
mathematically true, right?
Yeah. So look, let's break that into a couple of different components. I mean, I
Mm,
think certainly the AI that we're looking at, and we're science-based, and we've
mm,
got science-based solvers. Even the solvers approximate real life,
right.
but we
Yeah.
know over 40 years what that difference is. So we obviously use our solvers to solve problems. We then get test results. Test results have their errors as well. So,
Mm,
they're
mm.
also an
But it's
approximation of the
it's a
truth because
published
we want
error,
to.
right?
Yeah, exactly. It's a published error, known error. So with our solvers, we're creating AI, but that use machine learning. So
Mm,
effectively, they use the
okay.
solvers
Mm,
to create what we call virtual twin of physics behavior. So
mm-hmm,
basically, it's the shape that represents all of the acceptable designs for that
mm-hmm,
particular part, let's say,
mm,
that meet whatever physics behavior you're looking for. So it might be a strength test, it might be a drop test, it could be
mm-hmm,
multiples of those. And then you can use those to approximate. It's still an approximation,
mm,
but again, with known errors in that
mm,
approximation. Um, and the use for that, I think, at the moment, very much is in the engineering design space, where you really want to optimize that design. Today, what you do is you do the design, you send it to somebody to run the simulation.
mm,
It fails, they send it back. You do another design, like you do a couple of those
mm,
sort of loops. And just because of the time it takes to do that, typically maybe 3 loops might take about a month. That's about the most that people can do in a
mm-hmm,
18-month, 2-year design cycle for each bits of components and stuff. But if you can move that simulation approximation, and we know it's maybe 90% it's directionally accurate, or 95%, you can do that. Maybe it might take you seconds, so you might be able to iterate, change.
mm-hmm,
um, you are fairly confident now that your design will pass that final sort of testing or approval
mm,
step, and so you can
mm,
send it through and do that approval step. So I think what that does is gets you better products faster,
mm,
using that loop. But it's still accepting that that is directional, and you still have
mm,
that one last sort of test, which will get
yeah.
you to that absolute accuracy. So I think those sort of processes,
Mm,
are today very, very possible. Um, when you then start looking at large language models, so these
mm,
agentic AI, I think the hallucination effect is very real. And
mm,
so for people that don't know what that is, type your name into ChatGPT and sort of say, ask it something about yourself. It will come back with an answer. Often, if you do that twice, it will come back with a slightly
a different
different
answer.
answer.
Yeah.
Yeah.
Mm,
So I did that to myself once. I put in my name. It came back as the CEO of Geovia, which, as you
mm-hmm,
remember, is true, but just a little while ago.
yeah.
Did it the second time, it came back as CEO of SIMULIA, which is let's
Right.
call it the accurate version.
Mm,
So that's what a hallucination is. It remembers something that may not necessarily be
the
absolutely
current.
accurate
Yeah.
right at this point in time. Um, Now, the way to limit that in industrial large language models, so that's just a
Mm,
large language model that's consumed everything demonstrably in the world, and used for you and I to ask questions. You still need to question the answer it comes back with,
mm,
because it is, again, it's based on the logic that they built in, the statistical representations they built in, etc. Um, so you have to be very careful and questioning even how you use that. But in an industrial setting, I think there are two components. One is that you need to be very thoughtful about what you feed it, um, and and its logic as to how it sorts between, let's call it, worldwide information and specific to your industry or to your company information about
yeah.
how you want to go
So the
about doing things, your
guardrails.
processes.
Yeah.
Exactly. How you put those guardrails in. And then the other thing that prevents, or at least in industrial applications, reduces hallucinations is small, sharp competencies. So the way we're setting up our agentic AI is, it's not just one thing. We're going to break it down into competencies and then break it down into skills. Now, you don't know that when you're using it necessarily. It's a bit more fluid,
Sure.
but that's how it's structured. And so, again, reduces the hallucinations. When it comes, though, to engineers being concerned about their role and how this is going to impact their role, I say exactly the same thing to engineers as I did to truck drivers when we automated trucks in the mining industry. Absolutely, it's going to change your role, for sure. Will it eliminate it? We haven't eliminated truck drivers in the mining industry. We've changed their role and moved more of them, if I think about drillers, underground drillers, more off-site. We've moved them more into monitoring roles of now these fleets. We've moved them more into maintenance or training roles of these fleets, if we talk about the drills and some of the other sort of equipment. So their roles have changed. I think if I look at an engineer's role, definitely a lot of that repetitive stuff that you do now will be handled by the agentic AI. What you will be doing now is the more creative, because rather than sort of, having to wait around for your design to come back and be analysed, etc., or run numbers and simulations, you'll just be able to quickly do that. So you'll actually be able to do a lot more creative work around and optimization work and innovative work, because I can now put my change within the context of, the whole processing plant before I have to build it, or, all of that stuff that we spoke about. And certainly the couple of examples that I've worked with people so far industrially, yes, in the transport and mobility industry, or so car manufacturing rather than mining. But the one catch cry that I love, the guy came up with, was he said, this is bringing the joy back into engineering. Because rather than doing all that administrative, repetitive sort of stuff, now they can really focus on what he says is the real engineering. That creating
coming
something
up
new,
with
doing
creative
a design.
solutions.
Exactly.
Now, as you were talking, or many of the examples that you used were in the design space, right?
Yep.
Or conceptualization
project
space.
engineers and things like that. Yep.
To what extent do you see simulation moving into the operational space?
Yeah. So I think for me, it will move into the operational space. I think the big use cases at the moment are, how do we go from 10 years between, finding an ore body and ore flowing, which a lot of that is obviously the design space, truncating that down to 2, 5, whatever the number is. Some of that is in the build space. So again, how do you optimize the construction? And I think there's a lot of opportunities for AI to be helpful and virtual twins to be helpful in that. I mean, literally, how do you pre-build, pre-design, pre-optimize all of that, and then have a project plan that's super clear in terms of, how that's optimized. But then if you move into the production space, so there you go, well, so now I have this virtual twin that represents exactly what was built. And it might be slightly different from what I intended. But now I'm starting to get real data of how I'm operating this. So I can then even further optimize and simulate not only how it's working, how it might work, as I start trying to put in, new product or new ore body areas or geological information, whatever it might be that I'm putting in. How do I optimize my maintenance, based on, again, I'm starting to get these sort of pump numbers. What does that mean in terms of loss of throughput? How does that work commercially versus my, there's all those sorts of things.
But surely there's a difference between simulation and let's call it, optimization, which is a goal-seeking kind of exercise, right?
Yes. I mean, the two things are somewhat related. So, why do you simulate? To understand how that's going to work in the real world, or how this is going to work, is to ultimately improve your design, improve your product, improve your operation, etc. So that is true. I guess the question often is, how preemptive is it and how accurate is it?
Mm.
You know, so how far in advance of me actually having to do it can I understand it? Yeah.
And also maybe it could be very close to predictive analytics, where I could
Yes.
ask the question, what if things were to carry on the way that they are? What would
Yeah.
the outcome be? And now I could
Yes.
simulate that with all kinds of potential scenarios, and so it's almost that the virtual twin carries on where the digital twin ends, right?
Yes.
Um,
Yeah.
that kind of
Exactly.
scenario, and it is continuously informed by the output of the digital twin, and so on.
Exactly. And those
Yeah,
two things can interact quite happily. I
yeah,
mean, for me,
continuously.
generally the difference I make is a virtual twin generally has 3 dimensions to it,
Mm,
and a digital twin generally is 2 dimensional. You know, it's
mm,
optimizing very, and again, they can be quite sophisticated. So I'm not sort of saying that any one or less
right.
is more or less sophisticated, but they do interact absolutely.
Mm, mm. Okay, let's bring this then to maybe do some practical use cases or
Mm,
practical examples.
yeah.
Um, as you interact with customers
Mm,
around the world, mining and otherwise,
mm.
where do you see the first areas of adoption?
Yeah, so look, at the moment, I think some of the areas of adoption have been in the OEMs.
Hmm.
So especially the equipment manufacturers,
Okay.
the Caterpillars, the Komatsus, you know, the Vermeer, those sorts of companies,
Yeah.
where they're really looking at how do they optimize the design of their product, and then in the
Mm,
context, obviously, of where it's going to be used.
mm, mm,
You know, they're constantly wanting to innovate to obviously drive better outcomes for mining companies. So
mhm,
that's an area where I think you know, I'm seeing a lot of interesting adoption. Um, Also in the companies that design or produce processing plants,
mhm,
you know, and especially as we're looking to, you know, greater extraction ratios, more optimized processing plants, or even, you know, innovative, fundamentally
mm,
different processing facilities. You know, we want
mm,
them to use less power, smaller, greater
mm,
output. You know, all of the sort of holy grail. You know, again, we're starting to see those companies also adopt these sorts of technologies, again,
mm,
to run innovation, to run what ifs, but also in some cases that have been quite interesting, as we spoke, to bring back information of actual performance in
mm,
field,
mm.
and then, you know, create that more virtual cycle of improved
Yeah.
products.
So the
Um,
ML input kind of. Yeah.
Yeah, yeah,
Mm.
absolutely. And then the other companies that are really interesting are some of the power companies,
All
both
right.
from you know, at the battery tech end,
Yeah.
but also even at, you know, design of solar panels, solar arrays, design of wind turbines, and you know, interconnection of some of those characteristics. Geothermal. In fact, I just spoke to a
Mm.
company yesterday that specializes in geothermal plants, and obviously then
Okay.
distribution, and really again wanting to optimize, or not even optimize, wanting to simulate and understand and innovate, and then, you know, ultimately optimize those capabilities.
Mm. Mm.
Yeah,
That's
yeah,
yeah, that's amazing. And all of this, I guess, rides on this idea of thinking of the world or of industry as virtual first and physical second,
yes,
right?
yeah,
Yeah,
exactly.
which is a big conceptual change that has to be
Yeah,
made before you can truly adopt it. Michelle,
yeah,
it's been really interesting, and I continuously watch this space.
yeah,
Someone posted on LinkedIn somewhere during the week and asked the question, you know, which companies are really making progress in AI in mining,
mm,
and
mm,
to an extent, this is a complete mix between AI, I guess
yes,
classically speaking, and
yeah,
something that is very much rooted in the science.
yeah, yeah,
Right.
absolutely. Yeah,
Yeah. So, now all the best with that, and look forward to see
thank you.
where the simulation philosophy is being adopted in mining,
Yeah,
certainly as it is
fantastic.
in other areas. Now, I
Yeah,
I know, you just talked about all of the places that you've worked in.
Yeah.
I got to tell everyone what an absolute interesting mission it was for you and I to
Yeah.
to align our calendars and so on. So, given the crazy
True.
life that you are living,
Mm.
I always ask or rather, in the podcast, asking my
Yeah.
guests,
Yeah.
what do you do to remain human and to remain sane? What does
Yeah.
Michelle do when you're not simulating stuff or traveling around the world speaking to customers?
Well, that's true. I not only have the most understanding spouse who holds our family fort down,
Yeah,
but when I tell you where I go to remain sane, you'll realize how much they really are a bastion of amazement. But
yeah,
so we have a farm in Melbourne, in Victoria, in Australia,
right.
and it's about an hour north of Melbourne,
Okay.
and it is just awesome to go home, stand in some paddocks, lay in the fields, listen to the birds.
Mm.
We have 19 horses, so I get to hang out with the
Well,
horses.
okay.
We have 5 sheep, and they are the cutest things. Honestly, have sheep in your life. If I'd known that before I got dogs, I would have had sheep and not dogs. We've got five dogs and 3 cats. So in all, we've got about 32 animals that my spouse takes care of, and this massive farm while I'm
Yeah,
away most of the time. So, but that's connection with nature is how I
yeah.
keep sane, and whether that's at my farm, which I love, or whether if I'm in India, I try to get out into the rural environment. If I'm in I'm in Houston today, and so I'm
Mm,
hoping that maybe I can. There's a great big park just near me that's acres of park,
mm,
and so I'm
mm,
hoping to go and I don't know, touch some trees.
mm.
Yeah.
It's amazing how many people I speak with on the podcast that I asked that question to.
Mm.
Uh, Given that most of my guests are technologists of some sort
Yeah.
or other stripe, that the majority take it back
Mm.
not to, well, I relax with a nice movie or something like
Yeah.
that, but actually touching grass, right?
Yeah.
Or finding a mountain or going into the bush somewhere, or for some it's the
Yeah.
beach and so on.
Yeah.
And there is just something about that connection with nature that kind of
Yes.
sets things right again, doesn't it?
Exactly. It reminds you that you are a small part of a very big world, and
Mm,
that for me, many of these things have been here much longer than we have, and will be much longer after we're gone. So
mm,
we're part of a
mm.
continuum. We're a small part of a continuum.
Small part. Michelle, thank you so much
Yeah,
for being on the podcast. It's been
thank you.
so fascinating to listen to this, which I believe is very much going to be a much bigger part of our future than maybe
Yeah.
even we expect.
Yes.
Thank you for that, and I hope to hear from you soon again.
Fantastic. Thank you, and thanks everyone.